okay, let's be real for a second.
Yeah.
Getting a grip on all this application security stuff,
Right.
it can be overwhelming,
It can.
especially when you're just trying to, like, ship good code.
Yeah.
Make sure it's secure.
It can be a lot.
So much to think about.
Definitely.
How do you even know if you're focusing on the right things?
You know, it really is all about being proactive.
Okay.
Catch those potential weaknesses before they become big problems later on down the road.
Right.
And that's really what today's deep dive is all about.
Okay.
How to get that done.
All right.
Effectively implement static application security testing tools.
Okay.
SAST tools.
SAST tools.
Yes.
All right. So we're talking about tools that dig into the code,
The actual code.
the raw code,
Yeah.
looking for security problems,
Before the application is even running.
even running.
Exactly.
Okay. So before it even gets out there,
Cool.
we're trying to find these things.
Right.
The material we're looking at today
Yes.
gives us a really structured approach to this.
It's almost like a blueprint.
Yeah, like a roadmap.
Okay,
Yeah.
to build a strong SAST program.
Exactly.
Oh.
And we're going to break it down
Uh-huh.
into 5 key phases that
Uh-huh.
are outlined in the sources.
Right.
We're going to go through them all,
Let's do it.
starting with organization and security assessment.
Okay.
Then we'll move into the technical implementation and configuration,
Right.
how to actually get it set up.
Yeah.
Then we'll talk about integrating it into your pipeline
The pipeline.
and your workflow.
Gotcha.
And then we'll discuss fine-tuning and optimizing the whole thing.
Okay.
And finally, we'll cover scaling, training, and governance.
All right, so that's the whole picture.
The whole roadmap.
And we've got a pretty clear path ahead of us.
We do.
What I find really interesting
Yeah.
is how much emphasis there is on getting everyone on board
Yes.
from the top down.
Absolutely.
Executives,
Yeah.
developers, everybody in between.
Everyone needs to be on the same page.
Exactly.
It's critical. Plus, we're going to get into the details
We are.
of actually picking the right SAST tool.
Yeah, which one's right for you?
Right for you.
Because there's a lot out there.
It seems like it.
There is.
And we'll see some real-world examples, too,
We will.
where SAST has made a real difference.
Yes.
All right, so let's jump into phase 1, then.
All right, let's do it.
Organization and security assessment.
Okay, so this phase is all about laying the groundwork.
Okay.
Before you even start thinking about the technical details,
Right.
you've got to understand your current situation.
Yeah, figure out where you're starting from.
Exactly.
So what does that actually involve?
It starts with what's called a current state analysis.
Current state analysis. Okay.
Think of it like taking inventory
Okay.
of everything you have.
Everything.
What applications are you running?
All right.
What technologies are they built on?
Gotcha.
How do your development teams work?
Okay.
What security measures are already in place?
All right, so like a full audit of what you've got.
Okay. And this is really important.
It sounds important.
It is.
Okay.
Because it gives you the context
Right.
for a successful SAST implementation.
Makes sense.
And along with that, we need to think about stakeholder engagement.
Stakeholder engagement.
Okay, so this isn't just a decision for the IT folks
Right.
or the security team.
It affects everyone.
It affects the whole organization.
So everyone needs to be involved.
You need buy-in
Yeah,
from the
yeah,
top,
okay.
from the executive leadership.
Yeah.
They're the ones who are going to champion this
Right.
and allocate the resources.
Yeah, they're the ones writing the checks.
Exactly.
Yeah.
And it's not just about security folks either.
Okay.
You need a cross-functional team
Cross-functional, all right?
with people from development
Yeah.
operations.
Gotcha.
Anyone involved in the software development process.
Okay, so everyone has a seat at the table
Exactly.
to figure out how this is going to work.
And you need clear roles and responsibilities.
Right. All right, so everyone knows who's doing what.
Exactly.
Okay, and what about communication?
Communication is key.
Yeah, because if people don't know what's going on,
Exactly.
it's going to be a mess.
You need a well-defined communication plan
Okay.
to keep everyone informed
As the program goes on.
as it evolves. Yes.
All right, so once we've laid that groundwork,
Right.
got everyone on board.
Then comes the fun part.
Okay.
Choosing the right tool.
Tool selection.
Tool selection.
There are so many out there.
So many options.
How do you even know where to start?
Well, the material highlights a few key criteria
Okay.
to help you evaluate.
All right, let's hear them.
So first, you've got to consider language and framework coverage.
Language and framework coverage.
Meaning the tool needs to understand the languages your applications are written in.
Okay, so if you're a Python shop,
You need a tool that's good with Python
right?
and whatever frameworks you're using.
If you're a Java shop, it needs to be good with Java.
Exactly.
Makes sense.
And it applies to any tech stack,
Whatever you're using.
whatever you're using.
Okay, what else?
Then you've got detection capabilities.
Detection capabilities, okay.
You want a tool that can find a wide range of security weaknesses
All right?
and aligns with established security standards.
Like what kind of standards are we talking about?
So you got things like the OSPA Top 10,
Okay.
which highlights the most critical web application security risks.
Gotcha. So like the top 10 things you need to watch out for.
Exactly.
Okay.
Then you have CWE,
CWE.
which is a comprehensive catalog of software weaknesses.
Okay. So a big list of all the things that can go wrong.
Pretty much.
All right.
And then there's SANS,
SANS.
which is another leading authority on cybersecurity.
Okay. So those are some of the big names.
Some of the big names, yeah.
All right. So the tool should be able to check for all that stuff.
It should.
But what else?
Accuracy metrics are crucial.
Accuracy metrics.
Nobody wants a tool that's always crying wolf.
Right.
False positives.
Flagging stuff, that's not actually a problem.
Exactly.
Yeah, that can be a huge time waster.
It can.
You're chasing down things that aren't real issues.
And it can make developers lose trust in the tool.
Right, if it's always wrong.
Yeah, they start ignoring it.
And then you miss the real problems.
Exactly.
So yeah, accuracy is important.
Very important.
What about false negatives?
False negatives are even worse.
Worse.
Because that's when the tool misses a real vulnerability.
Oh, so it thinks everything's fine.
Yeah.
But it's not.
And that leaves your applications open to attack.
Yeah, that's not good.
Not good at all.
So you want a tool that's good at finding the real problems.
Absolutely.
And doesn't waste your time with fake ones.
Exactly.
What else do we need to think about?
Performance is another big one.
Performance, okay.
How long does it take to scan your code base?
Right, because if it takes forever...
It'll slow down your whole development process.
Yeah, no one wants that.
So the scan time needs to be reasonable.
Reasonable for the size of your project.
For the size and complexity, yeah.
Okay, what about integration?
Integration options are key.
Okay.
Can the tool connect to your source code management systems?
Like what?
Like GitHub, GitLab, Bitbucket.
Okay, yeah, those are popular.
They are.
Okay, so it needs to work with those.
It does. Does it play nice with your CI/CD pipeline?
CI/CD?
Yes. So your automated build and deploy process.
Right, so it can fit into that whole flow.
Exactly.
Okay.
And can it create tickets in your issue tracking system?
Oh, so like if it finds a problem.
It can automatically create a ticket in Jira.
Jira. Okay, yeah, that's what we use.
So it can fit right into your existing workflow.
Yeah, that's huge.
It makes things so much smoother.
Okay, what else do we need to consider when picking a tool?
Well, you've got the licensing model.
Licensing model. Okay.
So how much does it cost?
Right.
And how is that cost structured?
Okay.
Some tools charge per developer.
Okay.
Some charge per scan.
All right.
Some have an enterprise-wide license.
So you need to figure out which one works best for you.
Exactly.
Okay, and then finally...
Deployment options.
Deployment. Okay.
Where do you want to run the tool?
Okay.
Do you want it in the cloud?
Cloud.
Yeah. Easy to scale.
Less maintenance.
Okay.
Or do you need it on premises?
On premises.
Yeah, on your own infrastructure.
Okay.
Maybe you have some specific security requirements.
Right.
Or you want more control.
Okay. So you've got options there too.
You do. Some vendors offer a hybrid approach as well.
Okay, so you've got all these criteria.
We do.
How do you actually make the decision?
That's where the tool evaluation process comes in.
Tool evaluation, okay.
So you want to take a few of the top contenders
Okay.
and run them through their paces.
Put them through their paces. Okay,
Yeah.
how do you do that?
The material suggests a weighted scorecard.
Weighted scorecard, okay.
So you list out all the criteria we just discussed
Okay.
and assign weights to them.
Weights.
Yeah, based on how important they are to you.
Right. So if security is your top priority,
Yeah.
detection capabilities might get a higher weight
Okay.
than, say, cost.
Right. So it's like a point system.
Exactly.
Yeah. Okay.
Then you score each tool against those criteria.
Okay, and the one with the highest score wins?
Pretty much.
All right. But it's not just about the scorecard, is it?
No, you also want to do proof of concept evaluation.
Proof of concept. Okay.
Take a few of the top tools
Yeah.
and run them against your actual code,
Your real code.
your real code.
Okay.
The more realistic the code,
The better.
the better the results.
Okay.
Because you'll see how the tools perform
Right. In the real world.
in your specific context.
So not just some theoretical test.
Exactly.
Okay, what else?
You also want to compare the findings
Okay.
to any known vulnerabilities you already have.
All right. So if you already know about some problems.
See if the tool can find them.
Right.
If it can't, that's a red flag.
Yeah. That's not a good sign.
And don't forget about the developers.
For developers, right?
They're the ones who are going to be using this tool
Every day.
every day. So you
Mhm.
want to get their feedback.
Okay, on what?
How easy is the tool to use?
Right.
Is the interface intuitive?
Intuitive.
Yeah. Are the scan results clear and actionable?
So they can understand what the tool is telling them.
Exactly.
Okay.
And how helpful is the remediation guidance?
Remediation guidance. Okay.
So does the tool tell them how to fix the problems?
Right. not just what the problems are,
Exactly.
but how to actually fix them.
Yeah.
Okay, so that's a lot to consider.
It is.
But once you've gone through that whole process,
You'll be in a good position.
to pick the right tool.
The right tool for you.
All right, so then we move on to phase 2.
Phase 2.
Technical implementation and configuration.
So now we're getting into the nuts and bolts
Okay.
of actually setting up this AC tool.
We've picked our tool.
We've picked it. Now it's time to make it work.
All right, so what's the first step?
Infrastructure setup.
Infrastructure. Okay.
You might need to provision some servers
Okay.
or some cloud resources,
All right.
depending on how you're deploying the tool.
Right. Cloud versus on-premises.
Exactly.
Okay.
You'll need to configure network access,
Network access.
make sure everything is secure,
Right.
and set up authentication.
Authentication. Okay, so how people log in.
Exactly.
Okay.
Maybe through single sign-on SSO
SSO.
or API keys.
All right.
And it's important to monitor the infrastructure too.
Monitor.
Make sure it's healthy and available.
Right, because if the tool goes down,
Your scans won't run.
yeah, that's a problem.
It is.
Okay, so infrastructure is up and running.
Yeah. Now it's time for initial configuration.
Initial configuration.
Okay. So this is where you start customizing the tool.
To fit your needs.
Exactly.
Okay.
One of the key things here
Yeah.
is defining scanning profiles.
Scanning profiles.
So different types of applications
Yeah.
will need different types of scans.
Okay, so like what?
So for web applications,
Web apps.
you might focus on common web vulnerabilities.
Like what kind of things?
Things like SQL injection,
Teasful injection.
cross-site scripting, XSS,
XSS.
and cross-site request forgery, CSRF.
CSRF. Good.
But for mobile applications,
Little apps.
you might focus on insecure data storage
All right.
or weak authentication.
Okay, so different issues.
Different issues.
For different types of apps.
Exactly.
Okay.
And you'll also need to configure policy sets
Policy sets. Okay.
based on the criticality of your applications.
Okay, so like some apps are more important than others.
Exactly.
Okay.
So a public-facing e-commerce platform
Yeah.
needs more stringent security requirements.
Right, because there's more at stake.
There is
Okay.
than, say, an internal tool.
That only a few people use.
Exactly.
Okay, so you might have different levels of scanning,
Yes.
more comprehensive for the critical apps.
Exactly.
And then you need to define how your projects are organized
Yes.
within the tool.
And establish any baseline exclusions.
Baseline exclusions.
Okay.
Right.
So maybe you want to exclude third-party libraries
Third-party host.
from the scans
Right.
or automatically generated code.
So you're not wasting time scanning stuff that you didn't write.
Exactly.
Makes sense.
And then you've got repository integration,
Repository integration.
connecting the tool to where your code lives.
Okay.
So GitHub, GitLab, Bitbucket.
Okay, those are the big ones.
They are.
All right, so the tool needs to talk to those.
It does.
And what about branches?
You'll need to configure which branches to scan.
Okay, so maybe all the active development branches
Mhm.
and the release branches?
Exactly.
Okay.
And setting up webhook triggers
Webhook triggers.
can automate the scanning process.
Okay, so like when new code is pushed.
It automatically triggers a scan.
All right, so you don't have to do it manually.
Exactly.
Makes sense.
And of course, secure communication between the repository and the tool is essential.
Security is always important.
Always.
Okay, and then finally for this phase,
Rule configuration.
rule configuration.
This is where you tell the tool which security rules to enforce.
So like which standards to follow.
Right.
Okay.
You can enable rule sets that align with OWASP Top 10,
Oh, WASP?
OWASP,
Okay.
SANS 25 PCI DSS.
All right, all those big names again.
The big names.
Okay.
You also configure the language-specific analyzers.
Language specific.
So it understands the nuances of your code.
Gotcha.
You'll define how different severity levels are handled.
Okay, so like what's a critical issue versus a minor one?
Exactly.
Okay.
And you might even create custom rules.
Custom rules.
Yeah, if you have specific security requirements.
That aren't covered by the standard rules.
Exactly.
Okay, so you can tailor it to your needs.
You can.
And then quality profiles.
Quality profiles, yeah.
So you can have different profiles for different types of apps.
To ensure consistent and relevant scanning.
Consistent and relevant. Okay.
Yeah.
All right, so that's phase 2.
We made it.
We're moving right along.
We are.
Now on to phase 3.
Phase 3.
Pipeline integration and workflow design.
So now we're talking about how SAST fits into your development process.
Okay, so how it becomes part of the daily routine.
Exactly.
Okay.
And the goal here
Yeah.
is to shift security left.
Shift security left. What does that mean?
It means finding and fixing security problems as early as possible,
Okay, so not waiting until the end.
not waiting until it's too late.
Right.
So the material talks about a CI/CD integration strategy.
CI/CD.
So CI/CD stands for continuous integration and continuous delivery.
Okay, and that's like the automated process of building and deploying software.
Exactly.
Okay, so we want to integrate SAST into that pipeline.
We do.
All right, how do we do that?
Well, it starts very early
Early.
with IDE plugins
IDE plugins.
and pre-commit hooks
So like right in the developer's editor.
right in the editor,
Okay.
giving them feedback as they write code.
Oh, so they can catch problems before they even commit their code.
Exactly.
That's cool.
It's a great way to prevent problems early on.
Okay, so that's the first step.
Then at the commit stage,
Commit stage. Okay.
you can implement lightweight scans.
Lightweight. Okay.
So every time code is committed,
It gets scanned.
it gets a quick scan
Okay.
to catch any obvious flaws.
All right. So nothing too heavy.
Just a quick check.
Okay, what's next?
Then you have pull request integration.
Pull request integration. Okay.
So when a developer submits a pull request,
To merge their code.
exactly,
Okay.
you can trigger a differential analysis.
Differential analysis. Okay.
So it only scans the code that's changed,
Oh, so it's faster.
much faster,
Okay.
and it focuses on the new risks.
Introduced by the new code.
Exactly.
Okay, that makes sense.
And then before any software is released,
Yeah.
you have release gate integration.
Release gate. Okay.
So this is a more comprehensive scan,
The full scan.
a full scan,
Okay.
to make sure the code is secure before it goes live.
All right. So like a final check.
A final check.
Okay.
And finally, you have scheduled baseline scans.
Scheduled baseline scans. Okay.
So these are full scans of your entire code base,
The whole thing.
the whole thing,
Yeah.
run on a regular basis.
Regularly.
Yeah.
Okay. And why do we need those if we're already doing all these other scans?
Well, those other scans are more targeted,
Right.
focused on new code or specific changes.
Okay.
But the baseline scan
Yeah.
catches anything that might have been missed.
Oh, so it's like a safety net.
Exactly.
Okay.
And it also helps you find new vulnerabilities.
That have been discovered since the last scan.
Correct.
Okay. So it's like a double check.
A double check to keep things secure.
All right. So that's the integration strategy.
That's the strategy.
But how do you actually configure all of that?
Well, that's where pipeline configuration comes in.
Pipeline configuration. Okay.
You need to define the scan triggers.
Scan triggers.
Yeah, so what events should start a scan?
Okay. So like a commit,
A commit, a pull request.
a release.
Exactly.
Okay.
You also need to configure the scanner environment.
The scanner environment. Okay.
So where is the scan actually running?
Okay.
Maybe in container
A container.
for consistency.
Okay.
Or on a dedicated build agent.
All right.
And you need to set scan timeouts.
Timeouts. Okay.
So if a scan takes too long,
It gets killed.
it gets killed.
Okay.
And you need to define how to handle failures.
Failures. Okay. So what happens if a scan breaks?
Yeah, you need to make sure the pipeline doesn't just stop.
Right. It needs to handle it gracefully.
Exactly.
Okay. What else?
Caching can help speed things up.
Caching.
So it doesn't rescan unchanged code.
Right. So it saves time.
Saves time.
Okay.
And you need to make sure you have enough resources,
Resources like what?
like CPU memory,
Okay.
to handle the scans,
Especially for big projects.
especially for big projects.
Okay. So there's a lot to think about there.
There is.
And then what happens once the scans are done?
That's where results processing comes in.
Results processing. Okay.
So you need to define quality gates.
Quality gates.
Okay. These are like criteria
Okay.
that determine if a build is good enough to release,
All right. So like based on the number of vulnerabilities.
based on the number and severity. Yeah.
Okay.
You'll also set severity thresholds.
Very threshold. Okay.
So maybe you only block a release if there are critical vulnerabilities,
Right.
but you let minor issues through.
Okay.
And you can automatically create tickets,
Tickets.
yeah, in your issue tracking system,
Like Jira.
like Jira.
Okay. So the developers know what to fix.
Exactly.
Okay.
And you can configure notifications.
Notifications.
So the security team gets alerted
If there's a serious problem.
if there's a serious problem.
Okay.
And dashboards can give you an overview of everything.
Dashboards. Okay, so you can see the big picture.
Exactly.
Okay, so that's all about handling the results.
It is.
But at the end of the day,
Yeah,
it's the developers who are actually fixing the problems.
it is.
So how do we make that process as smooth as possible?
Well, that's where developer workflow integration comes in.
Developer workflow integration.
Okay, so IDE plugins are great.
IDE plugins again?
They give developers feedback in real time.
Right, as they're writing code.
Exactly.
Okay.
You can also integrate SAST results into pull request comments.
Pull request comments. Okay.
So the feedback is right there in the code review process.
Makes sense.
And just-in-time learning resources.
Just-in-time learn. Okay.
So if a developer sees a vulnerability,
Yeah.
they can get an explanation right then and there.
Right, in the context of their code.
Exactly.
Okay, that's helpful.
It is.
And clear documentation.
Clear documentation is essential.
Yeah, because if the documentation is bad,
Nobody will read it.
Exactly.
And it needs to be developer-focused.
Developer-focused.
Written in a way that developers understand.
Right, not just a bunch of jargon.
No plain language, clear examples.
Okay.
And then you need well-defined remediation workflows.
Remediation workflows. Okay.
So step-by-step guide on
Right.
how to fix the vulnerability.
So it's clear what they need to do.
Exactly.
Okay, so that's how we integrate SAST into the developer's world.
It is.
But it's not over yet, is it?
Not quite.
We've got phase 4,
Phase 4.
tuning and optimization.
So now we're talking about fine-tuning the SaaS process,
Okay.
making it work even better.
All right, so what do we need to do?
Well, one of the first things you'll encounter
Yeah.
is false positives.
False positives, we talked about that before.
We did.
The tool flagging stuff, that's not actually a problem.
Exactly.
So how do we deal with that?
You need a formal review process
Okay.
so developers can report findings they think are wrong.
All right.
And then you need suppression mechanisms,
Suppression mechanisms, okay.
ways to tell the tool to ignore certain findings.
All right, so like if you know something is a false positive.
You can suppress it.
Okay.
You can do this through code annotations
Get annotation.
or a centralized configuration file
All right.
with a justification for the suppression.
Okay, so you have to explain why you're suppressing it.
Exactly. And you might have temporary suppressions
Temporary, okay.
that need to be reviewed periodically.
Because you don't just suppress things forever.
Right.
Okay.
And documentation is key.
Documentation always.
Always.
Okay, so why are we suppressing this finding?
Exactly. And you need feedback loops.
Feedback loops, okay.
So the security team can analyze the false positives.
And use that information to improve the SAST rules.
Exactly.
Okay, so it's a learning process.
It is.
You're constantly refining the tool.
To make it more accurate.
Okay, what else do we need to optimize?
Performance.
Performance, okay.
We want the scans to run as fast as possible.
Right.
So incremental scanning can help.
Incremental scanning.
Okay, it only scans the code that's changed.
Right, we talked about that before.
We did.
Okay, what else?
Parallelization.
Parallelization.
Running multiple scans at the same time.
To speed things up.
To speed things up.
Okay.
And caching.
Hashing.
So it doesn't rescan unchanged code.
Right, we talked about that too.
We did.
Okay.
And you can schedule resource-intensive scans,
Like full scan.
like full scans,
Uh-huh.
during off-peak hours.
So they don't impact the developers.
Exactly.
Right.
And you can fine-tune your exclusion pattern.
Exclusion patterns, right?
If you're not scanning stuff you don't need to, host speaker.